With our unique sensor fusion technology, Zeabuz is going to transform maritime navigation. Here's how it works. Today, most vessels rely on a combination of radar, AIS, and human lookout to gather information about its surroundings. Our system uses advanced sensor fusion, consolidating the data from multiple sensor sources into a coherent and unified interface. Let's use this scenario as an example to demonstrate the various steps in our technology. With AIS, nearby vessels can share their name, position, and speed with each other, while radar provides a dynamically updated image of all objects within range. By merging radar and AIS, the interface now shows a single track for each of our detected objects. Let's add a short-range sensor, like LiDAR or 4D radar. Now we're able to detect smaller objects closer to our vessel, all integrated in the same interface. In our scenario, we've discovered 2 small objects nearby. To complete our sensor suite, we'll add high-definition cameras. With cameras, we can now classify the surrounding objects and track their movement with even greater accuracy. Everything from large vessels down to small kayaks or even floating debris. By fusing data from radar, AIS, high-definition sensors, and cameras, the system creates a single track per object. Through this approach, we've created a complete, dynamically updated representation of the traffic situation. The vessel now has full situational awareness. Motion planning and control. Here we have a vessel with full situational awareness. This allows a series of advanced features. First up, collision detection. The Zeabuz system detects all nearby objects in real time and tracks their location, heading, and speed. As our vessel is on collision course with an obstacle, the crew is notified through collision alerts, giving them ample time to react and navigate. Contrary to traditional operations, where the crew has to rely on experience and rough estimates, they can now rely on the system for accurate and precise predictions. Next, navigational advice. Based on the predicted trajectories of all surrounding vessels, the system automatically plans the most efficient collision-free route. The captain is notified of the new route advice well in advance of any potential collision. This greatly improves safety on board and saves energy through well-planned maneuvers. The Zeabuz system can comprehend and plan, increasing the intelligence of the vessel. Next, we connect our autonomy system to the propulsion system of the vessel, enabling it to also execute the navigational advice. Now we have a self-sailing vessel. The autonomy system has now given the vessel the ability to comprehend its own surroundings, plan the most efficient and safe course of action, and navigate automatically. Even though the vessel now is self-sailing, the captain still supervises the operation and can intervene at any time. With self-sailing vessels, a new era of operational possibilities emerges. As the captain's role on a self-sailing vessel becomes mainly supervisory, this function can be performed from virtually anywhere. This introduces the Remote Operations Center. The Remote Operations Center is placed on shore, allowing a single captain to monitor and supervise several vessels at the same time. With one remote captain able to handle the tasks and responsibilities of several on-site captains, the system is built to scale seamlessly and enable substantial cost saving. The remote captain has full overview of the operation at all times and is able to intervene, provide real-time support, and take control if necessary. The Remote Operations Center delivers scalable and highly cost-optimized operations, ensuring a safer, more responsive future for maritime fleets worldwide.